Hey everybody, this is Rydo and we're back to 7 billion humans. Before we jump into the game, there's some things we should mention, I think, when I was looking at the screen. These taller female characters, while we've seen them in the cutscene, they do kind of stand out when you consider every other character, regardless of age even, seems to be nearly the exact same height. So, I mean, you're talking about characters that potentially are 3, 4 feet taller than the vast majority of other people. That doesn't really make sense. And then they also all still have this weird half-tone artistic design. Now, obviously, they didn't need to put a lot of thought into the artistic design of these characters, but it doesn't really make sense because if it's supposed to be like a left brain, right brain thing, these characters don't really do anything with the half of their brains that is artistic and creative. They are just followers. So that's weird. And then when you see like a picture here, they're not two-toned. Like not two-toned in this picture either. Not two-toned this way. So you may have noticed as I scroll down there that I have gotten everything up to blue done. I spent maybe 3 hours at most doing all the little bonuses, and I'm just going to go through them and kind of quickly show the answers and just leave it at a few notes that I made. Basically, what I did for this one, which needed commands, was the least amount of commands possible to solve this one. And so this one is a fairly inefficient solution that looks to see if there's a hole in front of you or a wall. If there isn't one, it steps forward. Then it looks to see if there's to the lower right of you a hole or a wall. If there isn't, it steps forward. And then it jumps back to the beginning and double checks to see if there's a hole in front of you again. Otherwise, it then looks to the right of you and sees if there's a hole. If it isn't, it steps forward. Or, in that case, if there's a wall directly below you, then it steps forward to the right. So that's how I got it down to 9 commands. But you can see the inefficiency is fairly high here in that it took 24 seconds for something that they wanted to take 4 seconds to accomplish. The seconds still don't really make a lot of sense to me, but I kind of have figured out the solution through working all of these to make the game calculate seconds differently. And the main solution is pretty much just to have a lot of if commands. If there can be an if command, there should be an if command, which does make a, what I would say, probably flawed assumption as far as how many actual CPU cycles are required to make a comparison compared to not making a comparison. If you can write a robust enough software to just take the action and it won't matter if you take the action or not. Because in an if command, you're going to have to load into register a value, in this case the value of whatever you're standing on. Then you're going to have to load into register B a value. You're also going to have a comparison register, in this case set, which is going to be equals to. So then you have to run that comparison. Then you have to store that result into a register C, and then you return register. Well, I guess you don't have to store it into register C, but a lot of times you would want to store it in register C anyways. So return it. That's a lot of work compared to just, say, in a pickup command, load a location into register A and load a command which would be similar to probably the same type of command. Instead of equal equals, you would then say just pick up. This uses less RAM and it's less loading, so just doing it usually, and usually you wouldn't care in programming. You would just not bother to do it because it's to even care, because the differences will be in nanoseconds in most cases. It will be unperceivable by a human mind until you start getting into making programs that are working with billions and billions of values, and at a certain point even that stops being efficient enough to do on a single computer, when you probably should be throwing those kinds of program problems into distributed calculations, custom software across multiple servers, which like the Folding at Home project and such does. So my note here is, for this one, for speed, we have way too many jumps. So basically what it's going to do is it's going to see if you're standing on the cube, jump to the bottom, and from this point here is nothing but just a calculation on just how far to go before you get to the point where you drop it. So if you take steps, you pick up this cube. So this one, and this one will take 1, 2 steps, pick up a cube, then they'll be jumped to this point to take 1, 2, 3, 1, 2, 3, 4 steps. That's actually 4, and then drop it. Whereas this one will pick up a cube 1 step further, so they will jump past the first step and do the same thing. This one and this one will take 2 more steps, so they jump that way, and that's pretty much all it is. This is effectively a function, so if I had been able to just define a function where it was, if you're standing on the data cube, pick up, then exit, I could simply have just called the function and used considerably less lines of code, but there's no real need for it. Or there really is a need for function programming. In the sequel, since this is a sequel to Human Resource Machine, functions being introduced would have been really, really appreciated. And clearly they're not here unless some kind of God mode unlocks and we can go back and do all the programs with all the commands available later on. That would be very ideal even in the first game. So yeah, the way it gets faster there, and notice that took 4 seconds below the 6 seconds they wanted it to, is simply by having characters not execute code they don't need to execute, and just stopping as early as possible, and using a lot of if statements to break each individual character into their own program that's basically doing its own thing, which kind of then just makes a ridiculous argument as far as why there are so many people on the screen in the first place, and why you're having them all run the same code and writing a code that is so generic that it would work for each character, but then you have to write something completely different. And that's shown here fairly well, because this character is going to have to walk a very different path to fall down this hole than this character is. And all I do is simply have them all start at this point and then have them run the rest of the code. The other trick to keep this speed code to work is all they need to do is fall down the hole. They don't need to actually stand on each block and then follow these sets of instructions to go around in a circle. So I just programmed this, hard-coded it to step directly to where it needs to step. So after this point, it is just from here, go up, go this way, and well, you can even see it. So it moves a bunch of these to this point, and then they always do the exact same thing after that point. And it's just hard-coded programs to jump down the hole as quickly as possible, taking the fewest number of steps, which is to walk diagonally. There's a lot of cases like that where you just have to write a couple bits of code to get everybody in line so they all start at the same point. Which is not really where you would write a program. You'd want it to be more user-friendly than that. It's not very helpful to have a program that says, alright, everybody has to start at the same place with the same mentality so that we can get the same results. How many programs are you going to go, like a calculator program? How many calculator programs would be successful if you started by saying you have to push 1, then you have to press plus, then you have to press 2, and then you have to press equals, and that is the only way you'll get 3. And that is the only answer that this program is guaranteed to return is 3. That's not a useful calculator program. It should be you can press any button and it will give you the right answer no matter what. And even calculator apps on Android in particular are not particularly as good as they can be because they often limit the number of characters you can do. So when you try to actually do a big number, it fails for no good reason either. It just makes the values, instead of a 64-bit, which I assume Android can handle, a 64-bit floating decimal point number, it just kind of says, no, you can only have 12, maybe 24 characters, just because it would get too big on the screen. And that's not a good answer. That's not a way a calculator was. And what's weird is the default calculator on Android phones almost certainly do this. And so what you want to check always when you get a new phone, open up that calculator app and just tap a bunch of random numbers and then add 1 to it and see if it works after. And if that works, keep just multiplying it by like 2 or 4 and making sure that the number's right. What's really funny is that more often than not, it'll just give you an error message telling you we won't be able to do it, or it's not willing to do it. So this unzipper, I must have been a little tired when I did this. We have here a command which just says pick up the cube if you are standing next to a worker that is down here, or if there is a wall up here, which there actually in this case is a wall up here. So that is an or command that would only apply to this character. Step upwards. Otherwise, not otherwise really, just the next command is if there's a character up above you, then step downward. At that point, drop it, and then go back up to this point and loop. And actually, I don't even think I need the jump command here. So, let's see that work. Nope. I do need the jump command because this character can't decide until this character does. This creates a recursive loop, as it were. Now, when you play this game, it does... Oops, and you do need to pick it up again. So, this recursive loop causes a lot of people to do the same thing. And generally, you don't want recursive loops in your programming. But, yeah, that's how you get it to 7 commands. And I could probably put an if command in there. Then speed. Now the speed answer I accidentally ran into while I was working on the other command, and it's basically the same thing. Pick up the box. If there's a wall to the left of you, step up, then drop it. Otherwise, if there's a worker above you, step down, then drop it. If there is a thing, if there was a worker to the lower left of you, step up and drop it. Take note that this takes 11 commands instead of 8, but does effectively the same thing, but no recursive loop. Once a character drops it, they stop picking up things, they stop doing commands that they don't need to command. And it also certainly is a statement to how this game detects if you have succeeded or not, in the fact that you can get a win condition while the commands are still activating, which is not exactly what you would want. So next we have the speed solution for this one, which is fill in the holes. And this is just like super custom, this code, and I'm not going to go over it, but suffice it to say, this code would only work in this one pattern and only this one pattern. This is absolutely useless, non-robust, customized code that simply knows that you can go down that way and then check to see if there's a hole in front of you, and if there's a hole in front of you, walk forward and then drop and then stop doing things, and otherwise look to the top right. If there's a hole there, walk that direction and drop it. Otherwise look to the lower right or take a step to the right. Like you can see here, 6 seconds is way below the target that they expected, and it does go to show that these randomized tests are not making enough sense. In this case particularly, they needed to have where the hole is appear out of nowhere, and you could have easily animated that by just having the numbers shuffle around like we've already seen them do, but then have them blink like black instead. So just add a second animation where it's blinking up black and white, and they should have just said, okay, at some points, some of these 6 of these things, 6 of these data cubes will disappear. We probably should just step in this. So what it looks ahead at this point. If there's something in front of you, it walks forward, which is just going to be for those 2. And then everybody else looks to see if there's one in the top right, which is just, in that case, that one. And then that just has everybody else walk diagonally a couple points. And then it looks ahead again and looks at the top right again. Yeah. So, yeah, that's not a really effective or helpful way to learn, to just have somebody script out a solution. And then oddly, for the number of commands, 10 commands here, this is a super inefficient look down command, which is going to have you constantly looking down to see if there's a data cube in front of you or a wall and not a wall to the right of you. If it matches that, you're going to just step to the right, and that means you're going to snake to the right. Then if there is a wall in front of you and no data cube to the left of you, you will step downward. So it's going to snake to the right and then step down and then step down. Well, no, it's not going to step down 2 because at this point there will be a data cube to the left of you. Yeah, so it should go down, down, then here. And since there's a data cube to the left of you, you're going to then drop and then step to the left. So it's going to try and drop it over and over and over and over again, making it a super inefficient thing. So they're gonna, this is how I wanted to do this solution in the first place, but it didn't work for me when I first programmed this, and I found a different solution that was not really what I was hoping for. So you can see every time they say something, there's an error here, and it's just going to keep on going and going. By the way, there is a achievement for listening to the thoughts of each of these characters. So you can see how inefficient this is, that these characters are just still trying. They're still running all these commands, even though they shouldn't be. They should have just stopped. And if we had the in command in this instance, you would probably want to throw it in there. And see, this is incredibly slow to have it just snake back and forth, looking ahead, testing over and over again. Using multiple bits of information by testing if you're standing on a data cube and looking at the cube in front of you. But it does work. It's just not efficient, and then they're just going to get stuck in that area. And so that's how you do it in 10 commands. And that's probably the only solution, if I was to guess, of how to do it in 10 commands. So there's some solutions here for speed or the number of commands that are just not really appreciable, because the solution is just not good education. So there's an achievement for clicking on each of these and listening to them. I was in a stampede once. How do 3 seashells work? Mustaches makes the man. Armageddon is almost upon us. I prefer only braces. I am my own best friend. These are all like commands from comments from movies, and they don't say anything else. But that is a lot of work of writing that most players will not see. So I cannot really appreciate bothering to do that. And that jumps us to 18, which is the next one. So in 18, we had the speed, where it was at this point where the speed solution came in, that the thing I could only do to adjust the speed down to the requirement was to add an if command, basically, and add an ending command. So make it so it does end. So in this version, it is just going to pick up something and then step one time to the left. Then it's going to check for each person whether there is a shredder in front of them. If there is, give your data cube to them. Elsewise, every character is going to step to the right, which this person will be here, which means the person standing here will be here, and it will just stair step very nicely for a speed process. And see, this character just stops doing things at that point, making it a more efficient, speedier program. And this is one of those answers that gets both the speed and size challenge, which is not really what you would want. This was the original solution, and in this case it just keeps walking and takes that extra step and jumps into the shredder, which by just taking that extra step, that unnecessary step that will have it not be as fast, although that has fewer commands. So yeah, see, doing it that way and just having each of those characters jumped a full 11 seconds. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it went up 11 seconds because each one of these characters decided to do one extra command, then yeah, I guess that's what this is you get 1 second added for every time an individual character takes one extra command, which really just goes to show that seconds is absolutely the wrong word to be using in this case, because it's not seconds, it's number of steps. Steps per individual thread, individual core. Next, we have the commands for 20, the shortest number of commands here, at 9 to move this line backwards. And I accidentally made a recursive loop doing this the first time. Basically, they just pick up the cube and then they walk to the left until they see a hole, then a hole or a data cube. And this is still kind of a recursive loop. And that's, but I made a much worse recursive loop. It would be helpful if these programs told you the recursive the name of the thing you should probably Google if you're having trouble. Instead of calling this reverse line, they should probably just call this a recursive loop. And as far as speed, I accidentally did that when I was working on the commands, and it's effectively the same thing. It's just designed to reduce the number of steps slightly. I'm not sure it really did change much, because both answers took the same amount of time. Interesting. And I know in one of these I lost my original solution, but that's not really a big deal. And it was at this point that we started to hit some of these commands that really just needed the if statement to be replaced, where this before was if my item is greater than 49, step upwards, then give, otherwise else give it to this, and then step that way. And I just move that around, and by moving that around, that took out like a jump command, and that was all that was really needed. And so this works fairly well with the number of commands, but again, you see there's a lot of people that are popping up errors, and they are doing things, so that's definitely not an efficient command. And we had already done an efficient solution, so yeah, there's still at least half of these puzzles. You get the solutions fairly easily. And see, this is a very random one where the solution changes quite a bit just based on the random numbers they give you. It also opens up the door to there being some solutions that work in one very lucky instance and are very fast and very short, and you might get the challenges done because of that, but that's not really the way they meant for it to happen. And I don't think I would guarantee that they were smart enough to program these challenges to make sure that didn't happen. Their solution seems to be, if it fails more than 50% of the random tests, they then lock you into a failed scenario, so you have to rewrite your code at that point. Or you could just exit and then come back in. But I think you still probably succeed even if you only get like one success and can just move on to the next puzzle. So next we have a commands here that is just a super complicated if statement, and that's all it's about. So the trick here is to have only the people with the biggest number, when they pick it up, still on the floor. Everybody else needs to walk off. So it's just going to say, if your item is less than the person to the left or right of you, or above you, or to the up left of you or up right of you, or if you're standing directly in front of a hole, because you might actually, using this code, end up moving to this point where there is not actually a number anywhere around you to compare. So if any of those things are true, step forward. Elsewise, step to the right. And that works. Just a really super complicated code. If you didn't have the whole part there, they wouldn't walk downward. And it's not even a super inefficient code in that instance, but that definitely is not how I would want to solve this. And yeah, you can see there's a lot more logic in my code that I originally did, and it basically did the same outcome. Then we have here another speed, which all I did here is I added an if command at the bottom. So if there's a data cube in your hand, give it to the person to the right of you. That reduces a lot of the errors that I imagine the original one did. So here you see a lot of white popping up, and they probably should maybe make it just as a little bit more nefarious. Instead of just being a white speech bubble, they should have made it more obvious that you don't want to see these white speech bubbles ever, because that's a sign of slow code or inefficient code, characters trying to do things that they shouldn't be trying to do. The other thing is, this is one of the examples where if you're standing in front of a printer, you're given a loop of code that you're just going to do. If you're standing in front of a shredder, you're given a loop of code you're supposed to do. And if you're not standing in front of anything, you're given a separate load of code. Notice there's no white popping up here. People are just waiting their turn, and it does it. Maybe in reality this code executes a little bit slower. There is no real world timer, but the number of steps that are being taken are considerably less, because the game dismisses and discounts any if statement as being effectively valueless, where every execution command is counted as 1 second. And so that's how I got 48 seconds there. And let's see. The last one to talk about before we actually do something new here is the speed code here. And this is the worst example so far of breaking up the code for different people. So this one person is the only person that's standing in front of a printer. They're going to be put in an infinite loop to just take from the printer and give to the person above you. These two people are the only people standing in front of shredders. They're going to be given an infinite loop to wait till they have a data cube, then give it to the shredder. That's important not to die. And then it's going to look for if there is a worker in front of you, and in only this case, and this case is that true. So that's going to be given a infinite loop to wait till it has an item and then give that item upward. And then it's going to say if you're holding a data cube for this one, 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 it's going to then say if your data cube is less than 49, give it to the person to the left of you. Elsewise, it's greater than 49, less than or equal to 49. It's going to go the other way. So when you watch the green things, there's just like a lot of tests at the beginning to put people into loops to not have them run those if commands again. So these two are just going to go in their loop. These two are going to go in, these three are going to go in their loop. And these guys are going to go in circles, backwards and forward. Well, not backwards and forwards, forwards always in loops. Notice, again, you're not getting white pop-ups, but it is a fairly slow process to say the least. And it totally feels like that it is just a slower game compared to the original game, even when you do go up to 12 times. That definitely is not an efficient code. It is also probably worth mentioning that the target was 70 seconds and we made 69 seconds, and I cannot tell that it's not directly on the 70 seconds marker. That's fairly ridiculous. So let's see. Seek and destroy I didn't look at. Do I want to actually try and solve that on screen, or do we want to move forward? Let's see. Let's see if now that I've put in 3 extra hours, maybe I can think about this and we'll see if we can solve it. But I'm gonna quit fairly quickly, hopefully. How do we skip all this intro? Find and shred the smallest data cube in the room. And we have like 3 copies of this, and none of these work? That doesn't work, okay. So we'll reset that one. And that doesn't work. So we'll leave that one, and we'll just go ahead and assume that that one doesn't work. Find and shred the smallest data cube in the room. Okay. See. So, could I go back and get the code from Number Royale? Is that the one? Yeah. Yeah, this is fairly simply the answer to this. Also, like this kinda works with a little change. Okay. So if the number anywhere around you nearest data cube, pick up, step, to that, and maybe we don't even need the step to it, maybe we can just pick up to it. Right. And then we'll find the nearest worker and we will step to the nearest worker, and then we'll say or commands for days. Yeah, we're gonna have to also store the nearest shredder in mem4. That way we can go ahead and just give this to mem4. And gonna see, I don't know really how I want to do this to make this look nicely, because I want to go in, I guess, a counterclockwise motion. That way I make sure that I get each direction and don't accidentally miss one. Sure would be nice if there was a more efficient way that instead of dragging and dropping. This is part of the problem of any kind of programming. The dragging and dropping idea is just not an efficient way to work compared to just typing things, particularly in almost any field. Being creative, mouse movement is not as efficient as just typing things and having more inputs, more buttons. Okay, so left, up, right, up, right, up, right, up, left, left, down, down, right. Okay. And at this point, after you give it to it, we need to then find the next nearest data cube and go that way. This will probably error out if you're the only worker, but shouldn't be a problem. I don't think this is a super efficient one. Let's see how this steps through. Each find a data cube. They each compare around them. And then we have 92, which beats 24. 94, which beats 24. 92, which defeats 26. 28, which is less than 52. And 40, which is less than 52. And 47. So immediately all of those are rejected. And so those guys are all going to... What am I looking for though? Find and show the smallest data in the room. So, we need the bigger numbers, and we need to get rid of the bigger numbers, which means probably need this to all switch this direction, but we also need to figure out a way as far as what to do to drop the smaller number. I'm probably overcomplicating this quite a bit. My number is bigger, then just drop it and then step up instead of finding the nearest data cube. Let's just step up one and pick up what we're standing on. Which probably means we don't need to find the closest worker quite yet. Alright. We got a command here that's having them step to the sides. And I don't think that command is going to be needed. And even if it was, it's going to be a command to go that way. This jump here is wrong. Let's see. This command's not necessary. Yeah, it's really hard to see with all these errors, but I do think we did find the smallest number. We've just ended up with several small numbers in several different columns. And so at this point, it's just a matter of them dropping it. So what then you could do is, if above you is a wall, you can then test to see if you're holding an item. If you're not, get out of the way. So if my item equals nothing, go ahead and give to memory 4. Else step to the right. If to the right of me is also a wall, give to 4. See how that plays out. What this is going to do is inefficiently cause some people to just kill themselves for no reason. But it will help eliminate people so that we can just kind of go towards the right. So we just got a bunch of numbers there. If this is a... see, if this equals a wall, else it equals a wall, and if my item equals nothing, give to 4. It seems to give an error, so maybe we could instead just have them step downward. Get them out of the way. It would be nice to be able to just skip some of this. Right. See, we need to be able to drop items, though. Yeah. Testing to see if my item is the smallest. We're finding that we're at a wall. Feels like if I put the drop there, that doesn't really change anything. Really does feel like there should be a more efficient system here. Should get up to a wall. If your item equals nothing, step down. Could I add another step up function? Nope, that doesn't help anything. Yeah, there's something to this that I'm not quite getting, and I definitely have a fear that we'll get further into puzzles and run into this problem. But let's see what 42 has to offer for us. This might be completely different and way easier to understand. Welcome to my email inbox. Yes, each of those cubes on the floor represent one of my important emails. Your other boss said she would help me organize them. She was very nicely made 10 folders for me down there at the bottom. Those are shredders. And she labeled them 0 through 9. And she said we need to sort my emails into those 10 folders. For example, emails which with a number of 20 through 29 go to folder 2. Emails 70 to 79 go to folder 7. Emails with 0 to 9 go into 0. Got it? I don't really understand email, but I'm lucky to have such a good friend. Okay, thanks for your help, guys. Alright, well, this is easy enough. Nearest shredder won't work. We need to see. This is gonna suck. This is gonna really suck. Do not pick up the label 09 below each, directly above each shredder. They will explode. Which exploding is also an achievement. Alright, so store where the closest data cube is, I would guess. That's the first thing. And then there's definitely needs to be a case of let's see, hopefully this is integer math where I can just divide everything by 10. Any number below 10 should give me an integer result of 0. See. The nearest shredder now will be in mem4. We'll just keep it in mem4. If the value is less than mem2, step to the left. Else if the value is the value of the box I'm standing on is greater than mem2, step to the right. Else just give it to the person, to the thing directly in front of you. Okay. And then loop all of that. 12 commands. Let's see how that works. They're each going to pick up a cube. They're going to divide 9 did turn into 0. Okay. And I forgot to put in a command to have them actually step to mem4. It's always the simple errors. Nope. There's something here. I messed up. Something. I think probably simply here and there. We just needed the jumps, I imagine, a little bit differently. This is a lot of cubes, though. Definitely a lot of cubes. I think I've got this backwards, too. Yeah, by the looks of it, the numbers are not working right. Right, so they probably need to just stand and step the other direction. Yeah, it's always the little simple things. So this is a 0. Ah, but we do need a loop here. I told you not to pick up the data cubes labeled 0 through 9 on the shredder. So we do need a bit of a solution that is closer to this point. So if the thing directly in front of me is a shredder, don't pick up that. Instead, step upward. So slight fix there. Just had to put in some extra code to make sure it doesn't pick up the cubes. This should be a fairly efficient system. One hopes. One hopes that there will never be a scenario. Well, why did it pick up the thing? That's confusing. It can be slightly efficient in that it will go for the closest cubes instead of perhaps going for the furthest cubes. But it also feels like these characters could just go to the left while other characters could go to the right, and then they could just fight each other. Although they probably just move out of the way in that instance. Yeah, why did that guy, and see, this is just another great example of step backing. You should step back more. Mem1 to nearest data cube. Probably just need to move that jump, I bet. So it doesn't. No. Wow, this is a weird error to be running into when you have this exact code that says um, don't pick it up ever if there is the only pickup command here says if the spot in front of you is a shredder. Let's see. Well, if the spot in front of you is a shredder. See, I guess somebody is trying to pick these up while the spot in front of them is not a shredder. That must be the case. There must be scenarios where they get stopped. So. Step 2 min 1. If the spot in front of you is a shredder, go ahead and just pick it up that way. Changing the code just a little bit like that so that in theory they have to be standing on the data cube before they pick it up. We'll see if this works. Okay, we've run into a problem. Or if the thing above you equals nothing. And maybe it's easier if we just have it step up twice. See how that works. Now, the main part of this code that makes this work is this calculation that is just so easy to gloss over, which is to get the value of the cube and divide it by 10 using integer math, which means no remainders or no fractions or decimal points. But see, here's where you run into a problem. Is that once you get past a certain point, the solution falls apart again. I mean, theoretically this will probably solve it. And it by default has everybody just walking upwards into the middle before it starts to look for a cube, which starts from the middle, which is not really more efficient, it's less efficient. And in a funny way, this is like the first program we've done that actually resembles an actual program, something that would actually be useful, is to sort numbers. Usually you'd do more complicated math than just dividing by that number. Yeah. Still, though, you find a way to fail. So, complete in 200 or fewer seconds. We got that in 212 seconds. You might have noticed one or more of your solutions failed to successfully review. Yes, a red bar in the speed test indicates you failed the program. Here I've tried to reproduce the conditions where the solution failed. Try running your program against that right now. So now we're locked into a fail command. So that's the solution. How can we make this more efficient? Let's see. What I think you would do is step up one, and then if there is a worker to your left, step to the right. Let's see just how that works. What I want to do is ensure that everybody is separated. Let's see. See, I'm just making some real custom code. If there's a worker to your left, up left, go ahead and just step up that direction. See, I need this guy here, this girl here, and this one here. Wait, no, here. And then here. See, my thought pattern here was that it would be just easiest to try and do this by going down and then going back up and then going down and going back up. I'm not sure if that actually would make it any more efficient. Is there some other way we could reduce the number of steps? Let's see. Step 2. That. And see, if we had more than 4 memories, there would be an easy way to do this, I suppose. Because there's 5 guys. Could I have one of them know where these 3 were and then go look for data cubes that are specifically in that 3 group, and have one of them just decide to work that way. I think that would be a dangerous precedent. If in front of you is a shredder, step up. Or if what you're standing on equals nothing, step up. If directly above you is a wall, find the nearest and then step to it again. You each grab a block. Yeah, if below you is the shredder and what you're standing on equals, or what you're standing on equals nothing, step upwards. Else, just at that point, do that command. Step down. Step down. Just pick up. There. That's a little starter. I don't know how I missed something up there. Let's see. If my item equals nothing, at that point I could end, and that might be the only thing we really need to change. Just for an efficient solution here. And then we'll just bring back the 4 or 5 steps that we had. That's not the way to do this. There definitely is a commands way to improve this. Well, and they found a solution that doesn't work. Okay. What if we do random choice? We still have that as an option. Certainly. So, wow. So that's how you get speed. I guess if you just want to do it very badly, have a significant number of failures, but complete it in your successes fairly quickly by adding that randomization. But that definitely isn't an example of actually doing code the right way. In no way is that doing code the right way. So then the question would be, how can we put this so it's more efficient? So what we need to do is to say, you have no guarantee that any of these cubes would be below, wouldn't be below 10. So you can't test for the value of a cube to be 0 through 9. We need to be able to get to the nearest data cube. And we want to remove a ton of code. So how can we ensure? I mean, step upwards until there's a wall. Wonder if it might be easier to walk to a wall. No, because almost certainly the wall you'd get walked to would be here, and that wouldn't really help you any. So if this is not a wall, step up and just keep on doing that. And so at that point, when it gives it to it, we should just put this command down here. We'll just get rid of that jump command and do that. We'll need to get rid of anything like that. And probably means we don't need that. Probably means we don't need that code either. See if this works. So this will just be inefficient code that will just relay race back to the wall as a touch point, as a marker. And in theory, nope, that's the problem. You still do need a code to tell us to not pick it up. So if in front of you is a shredder, it's not a shredder, pick up 1. Otherwise, I guess just stop. Should be fine. Is there fewer commands to... That still doesn't work. Like, would it be fewer commands to say find the nearest shredder and go to the nearest shredder than it is to say something different, like just step downward until there's a shredder? I think there is one fewer commands that way. See. I think this is easier to write this way but I don't really need it to be that way, do I? If in front of you is not a shredder and you're not standing on a data cube, not standing on nothing, then pick it up. See if that works. A little confused as to what part of the code is causing these guys to they just don't have anything in their hands. If in front of you is not a shredder, which is true, and you're not standing on nothing, well, you are standing on nothing, so that is true. Does this just become an OR command in that case? Yeah, the AND OR commands do seem to twist around in my mind quite a lot. But it's usually fairly simple to say, well, let's change it from an AND to an OR. Yeah, we're getting there. It's just there still seems to be a scenario here where if this equals a shredder and this doesn't, I guess we'll just have to figure out how to write this so it's reversed later. if this is a shredder and what you're standing on is a data cube, do nothing except for step up. See if this works. Yeah, this is getting fairly complicated at this point. And so you can't find like the nearest other thing. That's the problem. Like if you can find this guy and then use him as a keystone and just call him a worker and walk towards him, that would be interesting, but that's not available to you. If you could have a wall marked or labeled in some place, I mean, I guess I could set my starting position. So what if we were to set this to mem3? I guess that works. And then I guess instead of having to loop, I could step back to just mem3 where they started. And that solves one issue and adds some efficiency, I suppose. So then the bit of the code that's being a pain is if in front of you is a shredder and you're standing on a data cube, do nothing, elsewise pick up one, and then only really at that point do you need to do any of that. Otherwise, and only at that point do you need the code to do that. Step to mem4. Otherwise, do that. Did I change too much in this code now? Let's see. if in front of you is a, so this one gives it to you, and then step back, then it should walk. Let's see if that works. Like, there should be a loop, I guess, about here that says until you figured this out and exited the loop, you should just keep on doing that loop. But it still doesn't seem to work. Like, if a shredder's in front of you and you're standing on a data cube, go into this function where it says if you're standing on one and it's less than mem2, go to the left, go to the right. If it's greater, go to the left. Elsewise, I guess maybe, could it be equal? I mean, that's what this really is that if it's less, go to the right. If it's more, go to the left. If it's equal, at that point, give it and then step back to where you were. And then at that point, this jumps back to, should be stepping you back to the top. Oh, well, that's the problem. I don't. Alright, let's just step through this, I guess. They know where they want to go. So now they should get into this code. And so this one is going to give a 21 to the 2, which should be right. And then at this point it should... I can't step to nothing. So that's the problem. Like, you should be able to just label where you were. And it would be kind of... Let's see what happens if we said step to where mem1 was instead. So in theory this should take them back to where they picked up that block. Did not work either. It really should be super, super easy. And yet it isn't. The nearest wall, I guess. That's what we'll do. We'll set it to the nearest wall, which at that point that should work because we're not changing the value of the wall. So go all the way back, touch the wall, try some more. But this is like 19 commands. So you can see that there's still going to be an issue. And I still don't know if this isn't going to do exactly what it did, which is just run into that same issue that we keep running into, which is it still wants to pick up a data cube. Hmm. Let's see if that works. Nope. The pickup part still, like particularly in this case, the pickup part is the problem. If in front of you is not a shredder, then you can pick up. Elsewise, step to 3. And find the nearest data cube. Actually, I think it might just be an easier elsewise. Step 2. 4. And see, I don't know if it saves me any commands to not just have it find the nearest shredder every time, because it kind of doesn't matter. I mean, you could always have these guys go down to the ones directly below them, but yeah. Let's see. If it's not, then you can then pick up that, and then you can do that, and then you can do that. There's a lot of lines of codes, a lot of jumps. See, I wonder if it is really just an end command is necessary to tell the people just to stop. That very well may just be the case, is that just to tell them to stop if they've hit a point where the closest one. See, if in front of you it's not equal to a shredder, Yeah, having to add lines of code to make it work definitely does not work towards the goal of having fewer lines of code. In all fairness, I would also say there's kind of a terrible system in which you would just never really want to try to drastically reduce the number of lines of codes, and you probably would never want to just have an arbitrary system where you're uh, specifically trying for an arbitrary number. Like, yeah, that just really wouldn't happen. I think this one can go. Let's see, and I think this one would be we need to move some things around here. So if I was to say if this equaled this, give it to, and then step back, else. Like this exit code, probably not needed. Instead, we need to phrase this in such a way that if the thing you're standing on is less move to the right, if the it's standing on is more, move to the right. And since an else command and an if command are effectively the same line, if the stand on it equals mem2, go there. Yeah, and the else end command, probably not needed. How else can we clean this up? Because we will probably need a jump. Let's see. Up to that. I kind of wish these were more bracketed instead of curved loops that are basically in the background. Let's see. What if we got rid of the test for the shredder, particularly in total? Just look to the left and to the right of what we were standing on. And then had something like this. Jump back up to this. which would then say this is going to be a pain to move the code, but yeah. If you're standing on a brick, move to the left. Let's see. We have to stop it from picking up 1, though. So, we do need a code to make sure we don't pick up one of these numbers. There's no way you're going to get away with that. Unless we just say, don't pick up if you're not standing on one. And you know what you could do here? And this is dumb. This is really, really dumb. You could do this. If the number is greater or less than mem2, randomly jump in that direction. That gets rid of 2 commands. Then that also lets you do this and get rid of a couple commands. Let's see if that works. So we add an incredible amount of inefficiency into it by saying no longer use any logic, just keep on trying with randomness until you have the right number. You can see it's going to take them a while. And then this guy's got a problem. He needs to find the nearest. So this is the exit code we would need to add. Which is just kind of out of the loop, for lack of a better way to jump. So this is 18 lines of command. And it is literally just going to be randomness. Will they ever cross their path? Though, that's my real question here. Or can you just get into an infinite loop that won't ever win? We've got everything else. Yeah, that doesn't seem like that's gonna work. Man, I wish they would stop with this BS of moving the undo button. The odds of you needing the undo button are fairly high. What if we then put a jump here and here? I mean, what if we just put 2 jumps here? And then got rid of this part, which then lets me get rid of that stuff. That gets me to 19. And if there was some way we didn't need the nearest wall memory, that there might be a solution there. We could potentially just give... No, we've got to test first and move left and right. So how do we get rid of these 2 jumps? Or get rid of this end part. And you just have such a high chance. The problem here is you just have a high chance of them continuing to try and pick things up without that end code. Which I guess maybe if you do it that way, then you don't need an end code. That way they only loop back and try a second time if they've successfully accomplished the first one. Nope, that still didn't work. You need a loop somewhere. You definitely need a loop somewhere. And there's way more than yeah, here's a number 3, so that would not work. We couldn't just say don't get a number 3 or anything below 10. Step to mem1. Yeah, I think I'm just so backwards in my thinking here. There probably is a whole different logical way in which this works. In which, if I just found the closest data cube and then tested if I'm standing on a data cube and there's a shredder not in front of me, then at that point pick it up. Pick up what I'm standing on. Yeah, and we definitely have hit a point where it took me 30-40 minutes to recap what I did off screen, which again I want to just emphasize no bamboozle there. I definitely did do those, but it is easier to say the least to do this kind of stuff off screen. There's a lot less effort that you have to put into it. Well, that almost worked. Like it is super easier to do these kinds of things when you're not having to be a video game critic and talk. And see, the trick here probably is if I just exited this and went back in here, that there's a decent chance now we have a randomized solution, so maybe my solution will work, whereas it won't work every single time. And so you might just want to cheat the game a little bit and see if you can find a solution that works. There you go. So like a wildly random, inconsistent solution, but a solution that works sometimes. And sometimes was good enough for me. Now, did I ever have a solution here that guarantees success every single time? No, I didn't. And it's probably not worth my time to... If this was a real program that actually needed to work, clearly debugging and optimizing the code and doing it the right way would be the right solution. But since it's just a game, no. Like I'm not going to spend the extra effort to come through this and figure out a solution. Now maybe that will bite me in the butt later on, because we may very quickly find that this is one of the very iterative puzzles compared to a lot of less iterative puzzles that we've done. So let's just quickly look at multiplication tables and then we'll be done. Oh no, all my email and data on my personal computer got wiped. How does this keep happening to me? Well, we now need to recreate this multiplication table so I can look stuff up. Like if a sandwich contains 2 calories and if I eat 400 sandwiches, how come I still want to eat more sandwiches? That's multiplication. See the grid over there? Each cube should be the product of the row and the column headers. So I'll leave you to rewrite those cubes. Pew. I haven't done this much math since 3rd grade. Alright, so the nearest data cube, and then if the see what do we want to, how do we want to do this? Should be fairly easy, because you just have everyone stamp up until they're at the top. So we just make a loop. If directly above you is not a wall, step to the top. They're a nice line So we already have everything in order for that. And then we set what will be the value of what we're standing on to memory 1. And then, well, you know what? We'll set that as memory 3. And then step down 1. And then we're going to set memory 2 to be a loop of 1. And then if memory 2 is less than 10, we will run a code here. You don't need to find the nearest data cube at all. And then what we're going to do is write the value. We're going to do a calculation of memory 3 times memory 2 and then we are going to write down, that should be the answer, memory 4. So we're going to write memory 4 to what we're standing on. And then what we need to do is just calculate memory 2. Like I'm probably using the numbers a little weirdly here. Equaling memory 2 plus 1. So this is a little trick I like to do in loops like this, where you are using a variable. Lots of people do it. It's not very unique, but you're using the indicator of the value that you're using to indicate how many loops to go to, also as the number to calculate the math. Okay. Let's see. One more step down, and that should be it. These guys are going to be slightly out of order, since some of them are going to hit a wall first. Something's wrong with my math. Something went wrong there, but let's step through this and see what happened. You desperately need a toggle that just says show us a break when we run into an error, so I can read it. Like, there's something here where it's not setting memory 3 right. No, we got memory 3. So now it goes down. And now it's saying memory 2 should be 1. So then memory 4 should be memory 3, which would be 2, times memory 2, which is 1, which should be 2, which should be right. Okay. Alright. Requires 2 more commands, apparently. You need to pick it up and then drop it. See, and because you just kind of know, you could optimize this a little bit better. Certainly. Let's see. So, what could we do, for instance, for speed on this? Is there... Yeah, I don't know what you optimize for speed here, because I don't know where is it running into an error. Very consistent at 67 seconds. We want to remove 6 steps, which there's more than 6 steps in each of these. Is there's some way you could hard code this more? No, not really. And there's no good way to come and pick up those bits of information. The only thing I could think would be to change the calculation a little bit, and instead of multiplying it every time, save the answer and then just add the previous number to the previous number. I don't know why that would really change anything now. To say mem3 equals mem3 plus mem3, mem4 plus mem3. Picking something up, writing it, dropping it, and then calculating a plus, and then testing. I mean, you could get rid of the if command. In theory, that should speed things up, but in practicality, it never seems like it does. If anything, it seems like this game hates when you do something like this. I mean, all that specifically is telling him is to just keep going. That gets rid of a couple of codes. And you can see that's not gonna make it any faster, but since we've already taken that step, why don't we look and see if we can reduce it to 2 more steps and get rid of it that way. See, if it's not a wall, go up. Could we get rid of the code? Step down. Zero. Remove a step. Step up here, 0. Then 1. Still need 1 command. And that added time, not reducing it. Let's see. Maybe you don't need to set it at all. Mim2, yeah, seems to have worked perfectly fine not being set to 0 in the first place. So yeah, that's how you get the commands to where it needs to be. And see, this is a supposedly difficult extra one, but I don't see that. I really don't see that at all. Is there a more efficient way to execute a command? And the if part, I think, is yeah. What you could do is reduce let's see, you could step forward here. You could then calculate Mim4 a second time as M3 times M2. You can once again pick up and then once again right, and then once again drop. And you'd think doing all of that really wouldn't change much, but it does reduce an if command, which you would think might be helpful. let's see how that plays. $67 still. So complicating the matter doesn't seem to fix it, unless we were supposed to just copy that each time, like 10 times. You can't set the value of something, can you? Like, would it be more efficient to get the value of the number above you and then add it to itself? No, I don't think so. I don't think that's the solution they're looking for. Is it more efficient to just not do that and just do that? Does that save the small few seconds? No, that adds more time. That definitely adds more time. Because it causes that error. Are we supposed to be finding out that for the first one we don't need a calculation because it's 1? Is that really what it is? It's just step down to pick up what's on it, right? The value of mem3, and then set mem2 equal to 2. And drop. It is kind of just a pointless extra bit of code that you wouldn't bother to do. Most multiplication usually is hard-coded multiplication tables in computers with the math coprocessor. There's not a lot of desire. Not a lot of desire to speed up ×1 multiplications compared to anything else. So that was 63 seconds, which is 4 seconds quicker, I guess. So how do you get those extra few seconds? Because if I was to do this one more time, it does seem like it's kind of ridiculous at that point to pick it up and then have to start doing calculations. Because I can't just, I mean, I can, but only in this case. I can pick up what's on here. I can write mem3 I wonder if it would be kind of easier to hard code this whole thing. Get a character, program them so that only one character is running at all. Wow, that would be a crazy idea. Program them so only this character that goes like in this corner here. Do I even have room for something like this? Does anything and everybody else ends. And then hard code all the math out at that point. There would just be so much extra work. You would have to hard code everything. Let's see. Step to the right. If in this direction is not a wall, end. See how that works. Step that way to the right. So that leaves like only this guy. Only one character. Which then theoretically I could just hard code this way and have him write 81 81 and then the next thing and then the next thing and the next thing and the next thing and the next thing, multiples of 9, and then I could hard code him at that point to go this direction and put 8 and then 16, 24, and I could just have him snake back and forth, and that would be a crazy solution that I think I want to do. So I hate to make promises I might break, but I'm gonna do that off screen, and almost certainly, because I have only one thread, only one computer doing the solution, and I just told everyone else to stop moving, I think this will be a super efficient way to solve this one multiplication table puzzle and absolutely nothing else. There's like no reason in the world you'd make a program like this. In fact, you're not even really making a program, you're making a macro at this point to do it that way with some flow control, which then kind of does make it a program, but I would definitely highlight this more as a macro. And I would, if I really cared, put some more energy into it and think about it some more and think of a real solution that would beat that goal. But the goals are still very arbitrary. And yeah, we definitely, in 2.5 hours, man, we have gone long, didn't make a lot of progress, and that'll hopefully change going forward. I might also go back and look at some of these also off screen. That's going to be it for this stream. As always, I ask you to like, share, subscribe, comment, and watch every second of my videos. If you want a friend or follow me on any social media sites, there's a whole bunch of links down below. And if you want to support me further, there's a link to Patreon, or you can support me by friending me on Steam and gifting me a game or a gift card. Thank you for watching. Have a good evening.